The question says that plot the corresponding reference circle for each of the following simple harmonic motions. Indicate the initial t equals to 0 position of the particle, the radius of the circle, and the angular speed of the rotating particle. For simplicity, the sense of rotation may be fixed to the anticlockwise direction, and in every case x is in centimeter and t is in seconds. So we have to plot four circles whose projection on the x-axis would represent a simple harmonic motion, and for simplicity the circular motion is assumed to be anti-clockwise direction. So for the projection to be on the x-axis, the one of the convenient way to represent the simple harmonic motion is in the cosine form. So our approach should be to first convert the given SHM equation in the cosine form, so that entire phase angle and everything would be very much clear for the case of projection on the x-axis. So in the first equation we see x equals to minus 2 sine 3t plus pi by 3. So here we can use the identity as minus sine theta equals to cos pi by 2 plus theta. So here minus 2 sine 3t plus pi by 3 can be converted to cos theta by adding pi by 2. Now upon addition we see that the equation comes out to be 2 cos 3t plus 5 pi by 6. Here the coefficient of t would represent omega, or the angular speed, so it is 3 radians per second omega, and amplitude or the radius of the circle would be 2 centimeter, and the initial phase angle is 5 pi by 6, which is represented using this. And at time t equals to 0, the particle would be in the second quadrant, or it would be approaching minus of x, or the negative maximum position in the x-axis. Now going towards the b, we get x equals to cos pi by 6 minus t. This is already in the cos form, so using the notation we will try to convert it in the positive form of omega. So here we get cos minus theta equals to cos theta, so it can be written as cos t minus pi by 6. Here omega is the coefficient of t, that is 1 radian per second, and amplitude is 1, so 1 centimeter, and the initial phase angle is minus pi by 6. Similarly, in the third form we have to convert the sine form into the cosine form. So we know that sine pi by 2 plus phi in theta equals to cos theta. So upon conversion we get these values as amplitude as 3 centimeter, and the x naught position is 3 by root 2 centimeter, and the time period is 1 second, and the omega or the angular speed is 2 pi radians per second. Now in fourth plot we have 2 cos pi t. So this is a simple curve which represents the initial phase angle as 0, or the particle is at the either maximum position or the minimum position. Since it is positive in its sign, so we can say that it is in the maximum amplitude position in the positive direction of the x-axis. So we can say that amplitude is 2 centimeter and omega is pi radian per second, because the coefficient of it is pi, so it should be pi radians per second, and its initial position is x equals to 2 centimeter, that is the maxima. Thank you.